one thing I forgot when I was kind of charting out our path, 4.4 and 4.5, they both address the same issue, but from different perspectives. So I think I was thinking maybe I would try to do both, but let's just make 4.5 extra credit. I'll talk a little bit about what 4.5 does. And the method it uses is good, it's just not the more general way to do these things. So 4.4 and 4.5, they both solve the exact same kind of problems. They just use very different looking approaches. You guys all good? And in the interest of time, I'm going to go ahead and say pass Jeff. That was a great poke, but no, we're going to make this one extra credit. How far did I post in WebAssign? I'm sorry, WebAssign peoples. I think I got it through 4. Is it through 4.4?
I think so, yeah.
Okay. I'll put 4.5 up there. And then, of course, it's extra credit, right? So you can do it or not. Okay. By the way, whatever grade WebAssign gives you is not your true homework grade. I think I've talked about that, right? Because the textbook people, I let them make some mistakes, but they still get full credit. So I do the same thing for my WebAssign people. Exactly the same. So, okay. All right. Any specific questions from anything? No. Oh, yes.
When should we see our homework grade from the last, like before the homework that was before the last test?
When should you get that homework back?
Yeah, I looked at some grade for it.
Oh, so what I'll do, you guys haven't gotten this from me yet, but like the grade sheet summary, it's gonna have a range, what your grade would be, what your average would be with no homework, what your average would be if all the homework was turned in and perfect. You guys kind of, I don't even know the homework grades at the day of the final, because when are homework corrections due? Day of the final. What's the last day you could turn in any homework? Day of the final, yeah. I mean, it's late if you give it to me after the test, but you could turn in chapter 1 homework on the day of the final and get more than 0 for it. You guys kind of, it's a bit, that's what's hard, 0. So I want to give you motivation to do whatever the hell, because the final's going to be cumulative. Exactly. Does that make sense? So,
In the last 2 days, right?
huh?
What's the finals in the last 2 days?
I'm pretty sure I did. Because, back in the day, not that long ago, you used to get 2 hours no matter what for a final, correct? Now we've changed things. It's supposedly a compressed calendar, even though it feels the semester feels the same length to me. But we don't get a final exam week. You guys know this by now, yes? Your test is on the last day of class, and if I did that, our final would be an hour and 20 minutes long. That's not good. You don't want that. So yeah, it's going to be over 2 days. We're going to have a part 1 and then a part 2.
And will we know like how it's going to be separated, or it's just like
I don't even know yet. I mean, again, I haven't taught this course in a while, and I definitely haven't taught every course under these new rules. You guys kind of with me? I think it was only last semester they started this, is that right? So I've only had one go about trying to figure out, like my pre-calculus class, 6 freaking units. No way in hell I'm going to make a final that goes for an hour 20. So, yeah. I had to do it over 2 days. I had to figure out how to break it up. And that was easy because I made one no calculator and the other one calculator. Yeah, because I got to ask them what sine of 60 degrees is. And I want them to get no help from the calculator. So you guys, I haven't really figured out. If I do determine something and I feel like it's something you should know, I'll let you know if there's a major difference between the 2 days. I'm kind of feeling like it's just going to be part 1, part 2. We'll see how much I feel like telling you. Okay. I mean, that's the way it is. Sorry. Any questions from homework or general questions? All right. How you guys doing? You guys doing all right? Spring break is close, right? No, it's not? It is. But it's not next week, so who cares, Jeff? Okay, I understand. All right. So if there's no questions from homework, I'm going to get back into where I kind of left off. I'm gonna truncate today's lesson a bit. We're not gonna leave early, don't get excited, but I just wanna give a big old chunk of time today devoted to just doing concrete problems. So can anyone tell me anything about, did I do this one already? I can't remember.
Yeah, we did.
Yes.
Alright,
Last one we did.
I love it. So just to remind me, can you guys tell me anything about this equation?
Second order.
Second order.
Two unique solutions.
Two solutions. I like it. Two linearly independent solutions. I like it. Homogeneous.
Linear.
Linear. What kind of coefficients?
Constant.
Constant coefficients. Okay, so that's the main idea of this section 4.3. If I have constant coefficients, and please, dear God, are you guys at the point where if you look at a DE, you should feel a little more comfortable to understand what kind of solution it should have? And we talked about this last time. So here, the derivatives of the function and the function itself have to be like terms with each other. The only function we know that does that is E, right? So that's why it makes sense that I would just kind of assume the form of the answer and kind of go from there. So we did this one last time. This is this word I always forget, but it's called the auxiliary. I'll probably misspell that, but too bad. Equation. So just to kind of truncate this, if I assume this is the answer, I should be able to now just understand if I did the derivatives, I'm going to end up here. And what kicks so much ass there is they look they look exactly the same. That's because E is so freaking nice. This also does not perfectly explain this, but how many answers am I guaranteed to have to that quadratic? 2. That's a fundamental theorem of algebra. Not F-talk, but F-TOE. Right? F-talk is the fundamental theorem of calculus, part 1 or 2. So that kind of relates how many, like Isabel just said earlier, how many answers should I get to the second order DE, homogeneous? I should get 2. 2 and only even that. So the order, if I had a third order, I should get 3. If I had a third degree polynomial, it must have 3 solutions. Are you guys kind of with me? So this is a little more concrete example about why that works, but it's too specific. The general idea is what I told you about last time. It's a little bit related to linear algebra with its infinite possible basis vectors and so forth, but don't worry about that. Okay. We just know now, the same way we know whatever the degree of a polynomial is, there must be that many intercepts, x-intercepts. The order of the DE, homogeneous DE, tells me how many independent solutions I should get. Okay. So we did this last time, right? We got m minus 2, 4m plus 3. A nice example of, you got to remember how to factor stuff, right? Now if I get here, don't just circle this and keep going, right? That's not good. What's the solution?
Y equals e to the 2x.
Good. I was going to throw that in a bit, but I was going to take it. C2?
And e to the whatever that is.
I understand. X, yeah. Okay. So if it is a purely homogeneous equation, I could expect possibly, let me do one little thing, okay. Hey, if I change one little thing in this, let me see if you guys get this. Okay.
Plus 6.
Wait, no, -1.
So the answer is going to be same stuff here, but isn't there going to be a constant solution? And I think I just heard it.
-1.
-1.
Yeah.
Let me stop for a minute. We've done this before. Didn't I ask you before what's the constant solution to something like this? And you could just look, the higher derivatives will be 0 if it's a constant solution, so I just have to solve -6y equals 6. You saw a few problems like that in the homework. If you're up to date with the homework. Okay. You guys all with me? I need you, but this is the most basic example of a non-homogeneous So what do I have? This is, what did I call this? And the book calls it this too, I think. I keep forgetting to look. What did I call this? And what did I call this? I don't know if you guys remember. You're all like, you say a lot of shit, Jeff. This is YC. This, YP. That's the particular thing that makes this happen. This is the stuff that makes it 0, therefore they work 2, because they get out of the way of 6 happening. I don't know if that's highly untechnical way to say things. If that makes sense, okay, maybe. That is the idea that's going to carry us through a lot of these next few sections. Find the answer to the associated homogeneous equation, and then you also find the particular thing that makes the specific function show up. So I didn't have to worry about that up here, because the particular thing that makes that show up doesn't matter. Okay. Plus here. Okay. You guys all with me so far? So this is really case 1 of what could happen with these things. The second case we already talked about. I don't remember if I did this problem yet or not. You guys can help me. Did we look at that problem yet? What would the auxiliary, and I don't care if you remember that word because I forgot it, so who cares? What's the auxiliary equation look like? Because we understand we're doing this, but we shouldn't have to do it all the way out because I know already what it's going to become. What's it going to become? 4m squared minus 12 m plus 9. Okay. Now this is case 2, so something different better happen. Does anyone know how to factor that?
2m minus 3.
Yeah. It's almost like so say it again. Okay, 2m minus 3, 2m minus 3. It's almost, if I made this a minus and got rid of that, that'd be a difference of squares. This is just a not difference of squares, so the middle term didn't cancel, right? So it's kind of like a failed difference of squares. So of course it would just be squared, right? So you seemingly get one answer, correct? Now, we understand in algebra that this is just a repeated root. But when I step up to differential equations, this will only give me one solution, and I know I'm supposed to have 2. So the answer it gives me is what? I love it. Now, we did reduction of order. I'm pretty sure I got to the point where I showed you the shortcut for these specifically. Let me know if I didn't. So the shortcut for this is you'll have this, but then x e to the 3 halves x. So that's the fantastic thing about repeated roots for constant coefficient, linear, nth order, homogeneous. Good Lord. It's like that's the person who's staying behind the star. When I get repeated roots, I multiply by x for another answer. And that x comes from reduction of order. That would be u, right? Y equals u times y1. You guys kind of with it? It just happens that no matter what the hell the specifics are, for this kind of DE, u is always going to be x. So let me ask you this. Let's go one step up. What if I had, okay, I'm not going to take time to do this. What if I had a DE whose auxiliary equation looked like this? Bring it down here, Jeff, so they can see. I only get -2. So what's one answer?
Plus c2x e to -2x plus c3x squared.
Good. So your gut, in this case, is correct. Hard part about mathematics is knowing when your gut is right and when your gut is like, nope, I don't know that. Basically the same kind of idea. I could kind of extend the reduction of order to kind of get that sucker, but this is almost too nice to believe that that's how these work. But again, it's based around the nicest function that exists for calculus, right? Okay. Maybe. So the third case. What's the only case we have in time? We talked about the case with two. For second order, it's got 2 real distinct roots. I kind of just gave it away. Then I've got the one where it's repeated roots, and of course the one we haven't talked about yet is everybody's favorite. was the one case I haven't talked about yet. Second order, that's only gonna have what kind of roots? Complex, that's right, kids. Very quickly, what's the difference between complex and imaginary? Complex has both, I love it. So every real number you've ever looked at is actually complex. It just has a 0 coefficient on its imaginary part, right? Major side note, okay. Bless you. Okay, all right, go as far as you can with this. You've been doing too much. You guys do it. Oh, I'm sorry, yeah. I was thinking, yeah, there should be a Y here or else this whole thing becomes a very different problem. Alright, so you gotta use negative b plus or minus arg. Right? Can't factor this. You can, but we just don't know what the numbers are, right? So I mean, you gotta use good old quadratic formula, right? You can never escape the damn thing. You could use completed square if you wanted to. So anybody got that quadratic going? Yeah. So I do get two solutions, of course. If there's going to be any complex, they have to come in pairs. You guys all know that, right? And this is why. Because they come from the quadratic formula. If my original has only real coefficients, every complex solution must come up with its conjugate. Right? You guys with me? Again, major sign. So I can write the form of the answer. This doesn't really violate anything. It's just that we have a better way to write it. What would the answer look like just accepting this?
E to the negative 1 plus I plus minus. And then
What has to go here?
x.
Okay.
And C to E to the negative 1 minus I x.
I like it. That is valid. That is valid, but gross. I don't want that shit. In fact, most of our problems are going to involve non-complex initial conditions and so forth. So I'd rather write this in a way, wouldn't it be great if I could write this without any complex numbers in it? All right, this could have something to do with my shirt. I don't know. Is anybody finally, yeah, everybody here, what am I talking about? Everybody here is taking calculus too, and if you haven't, what the hell are you doing here? So you've all proven this shit, yes? Taylor series? You do the Taylor series for cosine, the Taylor series for sine, you throw some complex shit in there, you add them together, you get the Taylor series for e, for the exponential. You guys got it. So this is true. This is a true statement. Right? So what does that have to do with this? First off, I want to show you, if I do, how can I break this up?
Do the negative 1 and the I component.
No, it's just a constant, right? For
E to the negative x
Oh, yeah,
plus ix, right?
yeah.
Minus ix, Jeff, you can do it. You guys kind of with me?
Mm-hmm.
So in this case, could I take the e to the negative x out? You guys all with me?
Yeah.
Okay. So just to kind of cut to the chase here. If I, in fact, let me give you this. Today, I am not going to make you sit through me. I've got it all written out, but I'm like, no, let me just give them the right paper, Jeff. That would be really good. Okay, here it is. If you use this idea you rewrite shit, and you do it for the general case. In which case, my answer could be, instead of e to the negative 1 plus I x, it could be e to the alpha plus beta I x. They could have different coefficients. Are you guys with me? And then if I do this idea, I can rewrite it in terms of cosine and sine. Because this is what that's based off of. It's cosine and sine. Real quick, you guys remember what is e to the I theta in terms of cosine and sine? I'm sorry, go ahead.
Plus I sine theta.
Do it again.
Cosine theta plus I sine.
Cosine theta plus I sine theta. You guys with me? You guys remember that?
Yeah.
Alright. I'm not going to prove it for you again, but e to the I theta equals cosine theta plus I sine theta. And again, that is just the Taylor series business. And that leads to this shit, right? By the way, the top is just a concrete example of a reduction of order. And then the bottom is these three cases that I'm talking about right now. So this is an example of if you don't want to apply the shortcut that we came up with. And to be really honest, are you guys at the point where you agree with me this is not a very long problem? I mean, a long problem, the further you get in math, a long problem is 1 page, 2 pages, 7 pages. Okay, now we're starting to get long. So this is nothing, right? So we did develop a shortcut that's got the double integrals. I don't know if you guys remember that. Integral of blah, e to the integral of blah. I don't know if you guys remember this. But actually just applying the concrete direct substitution we make leads to something that's not really that difficult, right? That'll allow you to do it either way you want to. But the important thing is down here, I get 2 complex solutions. If I use the whole idea I'm talking about, I can rewrite it in this form here. Now real quick, the I stuff is in these constants. So, just really quickly, I want you to really get this idea, because if I were a student in this class, I would have an issue with everything suddenly being real, it looks like, yes? If I wrote my answer as like, that, or I wrote, what's it better? It doesn't matter, Jeff. If I wrote it with like this, C would end up being related to I, and then these together would make a real number. So I am, here's one of my phrases I use sometimes, I am sucking the I in, but that allows my constants to be real. You guys so most of the stuff we're going to work with is going to involve real inputs, real outputs. So I would expect my solution should not have imaginary pieces to it. And they won't. It's not, unless, some problems might, but we'll see. Yeah.
I was gonna ask, does that mean that the coefficient components would have something that would make your I?
If you left I in, and you put in real initial conditions, you would solve for C and get an imaginary for C. So when you put it back in, they kill each other. Right? Does that make sense? So we sort of like go ahead and internally kill it. So if you want to see the full solution, you would see where it happens. And I could write that up if you want that. All right. So we have these 3 cases that we live in. First case kicks ass because the answer is just staring in the face. Second case still kicks ass, just not as hard. When you get one kind of repeated answer, you just got to throw an x in. If it was a 3rd degree like we just saw a minute ago, you would just keep multiplying by x's. If you had multiple repeated roots, are you guys kind of with me? And again, it's all because reduction of order would lead to that. We can just make a shortcut out of it now for these specific DEs. Complex roots are going to end up with this. This is, of course, going to be everybody's least favorite because you got to just construct that. Okay, so for the one we just did, where'd it go? Here. We ended up with this. What is alpha there? And what is beta? It was like, yeah, it was 1, exactly. So then I could write my answer, e to the alpha x. And by the way, just to remind you guys, wasn't it e to the negative x that I took out? And see how it's going to be e to the negative x times, right? So that's related to the e and negative x I would have taken out if I would have done all the steps instead of going to the, what I know the answer is going to look like. It's going to look like this. C1 cosine of x plus C2 sine of x. I like it. So that was a relatively nice one because these guys were relatively nice. Is everybody with me? Of course, when you do quadratic formula, you can get much worse shit. So if I would have done quadratic formula and I would have gotten this, sure. What would alpha be? 3/11. What's beta?
4/7.
Yeah, right? Who gives a shit? Do you guys understand? And then I just plug stuff in. Do you understand? They look gross. Who cares? I just plug them in. You guys with me? I just plug them into this form. Okay, alright. So, let's do this. Let's do this. Let's introduce this idea. I've been hinting about where we've been headed, and we're finally there. So, what do you mean, Jeff? I mean this. I should probably take one for the book, but let's see what happens to me if I do this. Let me do, sure. So in general, when I have an nth order linear, non-homogeneous differential equation, what I do is I first solve the associated homogeneous linear differential equation. Then I guess what the particular solution is going to look like. So a big part of today's lecture is going to be, how the hell do I guess the right thing? Because as a student, if we didn't some of this, you would realize, okay, I'm going to have to know what to guess to be able to do this shit. So can you guys take a minute and solve the associated homogeneous or homogeneous DE? I'm going to say homogeneous from now on, because I like that one better. You can say whatever the hell you want. What is the associated homogeneous DE in this case? Nothing amazing, right? All you have to do is what? There. And I don't know if you guys are understanding this is not cheating, this is nothing. If I figure out what functions make the DE 0, I can then add them to whatever makes the function, the D comes out to be X. Everything's great. So the full solution must include YC, which is what we're about to solve, and YP, which is the particular one that makes X happen in this case. So take a minute, figure out what that is. While I make sure I make one that's not too weird. Yeah, it's not too bad. Okay. Okay. I'm going to catch up to you a little bit. guys get there? Yeah, okay. So now I've got to go back. So this is set. I know this. The full solution is going to be yc plus yp. If it's homogeneous, then this would be 0. I don't have to worry about it. Stop for a minute. Is everybody cool with that? Does anyone know, this shouldn't be that crazy, what form the answer should be in? Why is that not quite enough?
Because if you derive that, then it's gonna leave something else behind.
Yeah, what's the derivative of ax?
A.
A constant, right?
Yeah.
And I need to kill that constant somehow, and I can't currently do it because I didn't give myself something to work with. So in general, I need this to make all the sense in the world. If my g of x, what's g of x in this D? What's g of x? X. I love it. G of x is just a poor little dude that's on the other side. You with me? If my g of x is polynomial, I'm going to assume the most general form of that degree polynomial is the answer. Why couldn't the answer possibly include an x squared term? What would the derivative of that be? It would be a degree of 1. Is there an x squared term in my g of x? No. So this would have an x squared term in it. This wouldn't. And of course, this dude would be
0.
well, this dude would actually, anyway, don't worry. There would be no other x squares to cancel the one I have here, so there would have to be an x squared there. You guys see that? I cannot assume the answer has an x squared in it, because this would be the only term that would have an x squared in it, and therefore, there should be a freaking 5x squared over there, and there isn't. I really need, you guys gotta see this, you guys see this. If I assumed y equals x squared, this would have an x squared, this would have an x, and this would have a constant. I could never kill the x squared. And why would I have to kill the x squared? Because there's no freaking x squared over there. It's just an x. You guys, does that make sense? Let that make sense. That is so beautiful. Polynomials always kick ass. So if it's a polynomial function over there, I just write the most, so if it was x squared, I would write ax squared plus, and of course I'm not done here, so anybody's concerned. That was my first guess, so we haven't finished this out. What should go here? Ax plus b, right? Okay. I just wrote down what somebody told me. We haven't finished this out yet. If this was x squared, I would write y equals ax squared plus bx plus c. I love it. This is kind of, you're going to see a lot of similarities between this and partial fractions, which I know is way up there on people's favorite days. Yeah. Are you good?
Me?
Lisa, yeah.
I think I was.
Okay. Sorry, I thought you had me.
No, I was just.
I can relate to not being sure if you're okay. Okay. So try it. Go ahead. I'll wait. We know the answer. I know exactly the answer. Let me throw that shit in there and see what happens. I should say, let me let you do it. I'll just stand here. Sorry. This will always be our goal. We have determined this so far, correct? And now I'm going to determine this. YC, and again, I don't remember if the book calls it YC. I think they do. It makes sense because that's the Y that's got the C's in it. That's the one that comes from the homogeneous. YP is the particular thing that makes the function that's there show up. So what are you guys doing right now? I'm curious. No way. Okay, Y prime is
A.
And Y double prime is? Nothing. That's awesome. So then this just becomes negative 6A. Is that cool? Plus 5ax plus 5b equals x. Okay. Do you guys see the similarities between this and partial fractions? Because now I'm going to equate coefficients, right? It's one of my favorite things in the world, but, you know. In case you're not as familiar with it, let me rewrite this so we can actually see what the hell's going on here. What must 5a equal? 1. Because there is an x on that side, whatever's in front of the x on the other side's got to be frickin' 1. So don't we know what it is? Yeah, will it always be this easy? No, of course not. This is a generally easy. So you know we're going to get A, B, C, D, E, F, G, H, I, J, K, L. No, maybe not. And then you could set, if you wanted to, you could set up a system of equations. You can construct it into a matrix. You could throw it in your calculator and get all the freaking answers out. Shit. Or for something this small, you better not be making matrices and put in your damn calculator. We know what A is, don't we? Does everybody see 5a must be 1? What else can I write down? Negative 6a plus 5b must be 0. Because there's no freaking constant over there, yes? I can directly see that. 5a must be 1 to make it x, and 5b minus 6a must be 0 because there's no constant over there, yeah? So a is, thank you, and then how do I get b? I don't know why I did all that, but too bad. So I get negative 6, I get 6 over 25? Is that all right?
Yeah.
All right. So something that happens sometimes is you'll get to this point, you feel like I've done enough work, but you're not done. Now I can write the answer. The answer is YC plus YP. What's YP now? Yeah, 1/5 x plus 6/25. You guys okay with that? Okay, all right. So, the only thing we can do from here on out is, a really good question would be, okay, I totally understand any polynomial you throw over there, Jeff. Polynomial? Sure. Check. Any polynomial. I'll owe it. I'll own that. That will be mine. Polynomial, just like aminals. A lot of aminals running around. Any polynomial I put over there, I know exactly what shape to it, what form of the solution to assume. It just sucks if it's x to the 4th, because that's going to mean I'm going to have a lot of A's, B's, C, D's, right? You guys going to follow? So, what if it's not a polynomial? So then a more general question is, when does this process work? It works if the g of x is a polynomial. What are some other functions that it could possibly work with? Probably e to the x. So basically, it's all of our nice functions. Cosine x, sine x. Those are nice, correct? Right? Anything else that are nice functions you think of? Natural log is interesting. Natural log is not too evil. It's a little bit evil. But is it something that we could do with this? Derivatives of natural log, are they related to natural log? What's the derivative of natural log of x? 1 over x. So do you see how that's an issue, possibly? Yeah, so let me show you this. In the book, they've got somewhere, I'm not going to write this down or give it to you on something, but this little table is a really good little table. So you can see exactly where, if this is what g of x looks like, then I'm going to assume the most general second degree polynomial, correct? All right, so all polynomials, easy to figure out what the solution is going to look like. The more freaking parameters I've got, the harder that part's going to be. Sine and cosine. Yes? E, kabam. Any polynomial multiple of E. Do you kind of see how that works? The polynomial piece is the same as it is if it was on its own, and then I just multiply it by the E piece. Let me stop for a minute. What this really involves is if I assume the form based on this, it must cover my ass for all the possible derivatives of this. Does that cover the basis for the derivatives of this? Every derivative of this is going to look like what? Every derivative is going to look like, I don't care about numbers. I don't give a shit about constants. You're in calculus. Y'all, you've taken calculus. You know constants don't mean shit. I can make them do whatever I want them to do. Yeah. Every derivative of sine 4x looks like cosine 4x and sine 4x, right? So that covers my ass, doesn't it? You guys, and again, what's the idea there? I will be taking derivatives. I will be adding them together. I need to have parts that can go together. So this is just completely covering my ass. What if I didn't need a cosine 4x? Well, then a is going to be 0. I need it there, though, in case I need it there, right? If you remember partial fractions, if you didn't write the most general form and you needed it there, you're screwed. You're never going to get the answer. Okay. So the funkiest part of this, I believe, let me see if they, all right, this is, no, it's not even that funky. Yeah, none of this shit's funky. Here's the funkiest little thing, not even this. They all are the same. I'm thinking about in the future, we're going to get some funkier shit. This guy, how many function factors does it have? 1, 2, 3. So the x, I'm going to write the most general polynomial. E dude is the nicest thank you for existing, little E dude. You're awesome. And then I've got to have a cosine, and then I have all the same shit with a sine. Do you kind of follow how this is put together? Let me stop for a minute. This is new. This is kind of to help us figure out what form to assume the answer takes, right? Yes?
On the point of logs, don't log base like A have logs in their derivatives?
Oh, but they would be logs of that constant base, not functional logs. Does that make sense?
Oh, okay, so
Yeah,
they would-
yeah.
got it.
Okay. But that's a good point. I like it. One of the lesser remembered derivative rules is for like log base A of x. Yeah. Okay. But you're right. It does have a log, just not the right kind. So, did I just give you that? No, I haven't. So let me give you this. Today is concrete problem and mini papers day. So you can see why this is this section is called undetermined coefficients, because it's all about finding A, B, C, D, blah, blah, blah. We don't know what the coefficients are. We got to figure them out. I kind of just put this down there just to remind you. This is kind of like the idea of superposition, where if I know a couple solutions, I can put them all together, right? All right. So there are some funky things that could happen in these problems, which should not be too surprising. But I give one example, kind of like the one we just did. So you kind of go back to that. I give a little idea about when this method works. And of course, undetermined coefficients is coming right off of the nth order linear homogeneous constant coefficients, right? So it still is assuming we have constant coefficients. It's linear, all these kind of things. The new thing that we're looking at is the g of x function exists, those non-homogeneous ones we're looking at. And then I need to have an idea of what kind of functions can I do this process for. So in case you're curious, Couldn't g of x be cosecant, for example? G of x could be whatever the shit it is, yes? So g of x could easily be cosecant. Would this method work? Would this method work? Is cosecant one of these things?
Technically a side.
Is a finite sum
Finite sum
of product.
or product, not a reciprocal.
Oh.
You guys with me? So cosecant, so that we're gonna learn how to solve. If I had the exact same problem we did, but it wasn't equal to x, it was equal to cosecant of x, we'll be able to solve that in section 4.6. Yeah. Section 4.6, the title is Variation of Parameters. How does that make you feel? Intimidated? Concerned? Anyway, if it makes you feel warm and fuzzy, that's awesome. It's not so weird, but that's all right. Excited? I like it. Bring it, math boy. Yes, sir.
I still don't understand how that excludes cosecant, the finite sum.
Can you construct cosecants from any of these functions through a sum or a product?
Isn't the 1 over thing?
Is that a sum or a product?
I thought it was a product.
No, definitely not.
Okay.
Yeah. I'm sorry. I don't mean-
No.
1 over something is its own function, right? A reciprocal function. It's not a product. I didn't take something and multiply it by something else. Right? Can you take any of the functions described in the first 4, multiply and or add them and get cosecant? No.
So with tan work, so you just multiply if there's like sine.
That's division of 2 of those functions, right?
It would be product if there's a.
Reciprocal, which again is not it here. Does that make sense? Okay. Alright, stop it. Otherwise, I would have just, where it says sine and cosine, I would have just said any trig function. So the fact that I specifically put up here, and not just me, just the process, can only work with sine and cosine directly, is because they are directly related to their own derivatives. What is the derivative of cosecant? Negative
Cosecant, cotangent.
cosecant cotangent. So all you gotta remember is secant x derivative is secant tangent. And on the quotient, it's always a negative with the quotient in it, yes? Which you finally now fully understand why we call certain things co and certain things not co. Yeah.
So it's H sign works, and it's product. H sign works, that's product, or sign X.
Oh, yeah. Hyperbolic sign is a product and a sum of e to the ax, correct? I don't know if you guys remember your hyperbolic trig functions.
Is that the coach?
Cosh and the sinh, yeah.
Oh,
And the
yeah,
sich.
hyperbolic.
Cosech. But just the sinh and the cosh could be a part of this. I'm not gonna focus too much on those, because sometimes some of your teachers just skip over that. Has anybody never heard of hyperbolic trigonometric functions? That makes me sad, but it's not your fault.
When did you know?
Pre-calculus.
Oh, pre-big
Oh,
Yeah.
I did not.
Totally pre-calculus.
I didn't learn about that.
Oh, okay. Yeah.
I heard about it, I don't know anything about it.
Very quickly, guys, just to give you a little teaser. What are the basic trig functions defined on? Circle, unit circle. So hyperbolic trig functions are defined on the unit hyperbola. That's all. So maybe if you've never heard of them, you can go look them up. So center is 0, 0. But then, let's see if I remember. It's been a while. It's like x squared minus y squared equals 1 is your unit hyperbola. It's related to x squared plus y squared equals 1 is a unit circle.
And that's why now we take the derivative, that's why there's never negative because it's impossible.
Yes. All right. We're not going to focus a lot on hyperbolic. But just to show you very quickly, if I remember correctly, I think the book does mention it. Am I in the right place? I think the book mentions it somewhere, but I can't remember where it is, to be honest. No, it wouldn't show me that. Anyway, not that big of a deal. I need you to understand, if you've never heard of hyperbolic trig functions, to be really, really, really honest, they are just combinations of e to the x and e to the negative x. So if you take, let's see if Jeff remembers, e to the x plus e to the negative x divided by 2, I think that's sinh. Remember? Sinh, hyperbolic sign. So you could look at it as if we took all that shit and just gave it its own symbol so I didn't have to write all that shit. You guys kind of follow. That is one way to look at hyperbolic trig. We are going to right now stop talking about hyperbolic trig. Because it's not that big of a deal. But if you've never seen it, you really should go look it up. You really should. Okay. So let's look at the other side of this thing. Let's do a couple things. Can you guys please solve the auxiliary, the associated homogeneous? Anyone notice anything? We're not going to do anything with this. But does anyone notice anything weird about this differential equation the way it's given? There's no y term. I love it. But so there's certain things you could do. We're not going to look at it like that. Just go ahead and make the auxiliary equation to solve the associated homogeneous. You guys got it with me? If you have no idea what to do right now, call me over. Not that big of a deal right now. Yes? No, right now, I want you to figure YC. I just want you to figure out the associated homogeneous. And then I'm going to help you with the YC. Oh, I should put.
Just wanted to make sure, I don't know how to factor variables, I'll be honest.
Oh yeah, well you always try first with your factories on the teach. Great common factor. I'll try to take right. So GCF, we try to take something out.
Right, so to just take out.
Take out GCF saves your ass. So you always try GCF first, because if that can be done, it might be the only thing that's done.
We did the square that we did over here. I always just gonna mix up. That's when you take the middle term, split it in half and square, or is it?
Yes, the middle term. So I would move the 2 over, cut that in half and square it. That tells me what to add. And that is what tells me what to add, so it factors like something squared.
Okay.
That's why we call it completing the square. What's it missing to
But
make
then
the
when you
square?
add it, you also have to have that equal minus that same thing because we can't just add.
Exactly, whatever you, well, in this case, we do have 2 sides, it's equal 0.
So then it's, okay.
If you do it all on the same side, you have to make sure you undo what you did, yeah.
Okay. And that's why you would want to just bring that 2 over so now over.
But how do you know when you have to synthetically divide something?
Oh, good, good. We are gonna talk about synthetic division in a bit. In fact, I'll do it right after we do this, because it's good to remember. So we'll talk about it. Yeah. Does anybody think they don't know synthetic division?
I learned yesterday.
Does anybody think you've never heard of synthetic division? Who's forgotten synthetic division? Okay. All right, guys, help me out.
0, -2.
Now this is kind of nifty. What happens here?
Just get a constant.
C1.
You get C1 e to the 0x, correct?
Yeah.
So that's just C1. C2 e to the negative 2x. So that's my YC. So I've got that part set. Now YP, because you should, is involving what's the form of the answer. Do I have a function that's composed of multiple factors of functions? Okay, does that make sense what I said? Yes, sorry.
So the prompt would be like and plus b e to the c.
No, careful. It's a really good point you're making in that question. It's going to be ax plus b to cover my ass for this linear, yes?
And
Multiply by e to the x. Now, a really good, this is interesting, this is coming up now, I like this. A huge part about differential equations is knowing where the shit do the constants go. Do you all agree there's no way it could be e to the 5x? So there's no way it could be anything except e to the x. Do you guys understand? Because if I start with e to the 5x and I take derivatives, I'm never going to end up with e to the x. It must be e to the x. You guys with me? So normally, I won't say normally just to cover my ass, but most of the time, we are not going to put a constant into a function. So inside of the e, inside of the sign, blah, 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 right? We're not going to put a c. So if it was sine of 4x, I would assume the answer is a sine 4x plus b cosine 4x, not a sine bx. I know it's 4. It's got to be 4. There's no way that through derivatives make it not 4, so it must be 4 in the answer. Does that make? So here, it must be e to the 1x. All right, and then what do I do? No way. So everybody's favorite thing? If you wanted to, you could distribute, right? So you don't have to do product rule, whatever. You still have to do product rule, so haha. But so it's going to be derivative of this guy times this guy plus this guy times the derivative of this guy. Yes? Good old product rule. Next derivative. I'll do this part. Okay. Let me see if you guys have noticed this fact. Didn't we just get the original function again? You guys with me? Didn't I already take this guy's derivative? Isn't it this? So aren't I just going to add this shit?
Yep.
You guys see that? That happens often enough that you make it a little shortcut. So I'm actually going to end up with 2 of these plus another one of these crazy ass things. You with me? Probably going to need more room than I gave you. Too bad. Maybe. Let's see what happens. Almost definitely, Jeff. So if I throw this stuff in there, I'm going to get 2a e to the x plus ax plus b e to the x plus 2a e to the x again, right, guys? I got a double y prime. Is that cool? So I just put y double prime. Bam. Now I'm going to put twice y prime. And that's going to equal 9x e to the x. So yeah, let's get some other paper going. I mean, stop for a minute. Now I'm hoping most of you guys realize if you can really understand the form of the assumed solutions, if you can really understand how to pick those out, this just becomes a number game, right? Now it's a number game that a lot of us don't want to play. This one's nice. I don't give a shit that that's long. How many letters am I trying to figure out? Okay, it's got to be nice. There's no other question. It's got to be nice. It can't be bad. It's got to be nice. It only gets bad if I have more than 3 things. A, B, C, D, E. Oh my God. Right? So let's see. What do we got going here? Let's collect some like terms shit together. So I got 2a. Let me see if you guys are cool with this. 2a plus b plus 2a. Just put it, Jeff. You're okay. Plus b e to the x. Sorry, should be 2b. Is that all right? So there's my 2a e to the x. There's my b e to the x. There's my 2a e to the x. There's my 2b e to the x. Shabam! I'm looking at coefficients. Are you guys with me? You guys all right? It's okay. I don't need an answer. And then let me collect all my, what's the other stuff I gotta collect? I got all my e to the x stuff together. Now I've got to get my x e to the x stuff together. So I have a x e to the x plus 2a. I'm sorry, where am I? Yeah, 2a x e to the x. And again, you don't have to, I'm doing a few steps at once here. Are you guys all kind of with me? I mean, the next thing, the whole idea is equating coefficients. So I want to get all my coefficients of my stuff, my e to the x and my x e to the x. So what does all this have to add to be? All of this has to add to be what?
X.
Is there an e to the x term over here? Y'all understand that there is no e to the x term here? Do you guys understand what I'm saying? There's 9 x e to the x's over here, yes? There are 0 e to the x's over here. Are you guys with me? Therefore, all of this shit has to equal, how many e to the x's do I have? 0. Okay. So this must be 0. And of course, what was this equal?
9.
Because I have 9 x e to the x's. So I'm just equating coefficients. How are y'all doing? Okay. This is a weird way to weird time to put this up here, but I got to do it while I'm thinking about it. Quiz, Tuesday, section 401 through 4. Sorry to do that to you in the middle, but I have to put it there while I'm thinking about it. Is everybody with me on this? Not necessarily your favorite thing to do, but relative to some other shit you have been through, you have to agree this is not bad. I know some shit you've been through. I put you through some of that shit. Alright, so what's A? Holy. And then what's B? -4. Kick ass. So therefore, what is the solution?
3x minus 4.
C1 plus C2 e to the -2x. That's my YC.
3x minus 4 times e to the x.
Yeah, it'll be 3x minus 4 e to the x. This is the part that makes it 0. This is the part that particularly makes it 9x e to the x. So the part that makes it 0 does not screw with the part that makes it 9x e to the x. It just kind of gets out the way. But I have to include it because they do work. So real quick, I need you to understand this. Is one solution to this 3e to the -2x? I really want to make sure you guys understand. Because what's the piece of this solution that I have no control over? Does that make sense what I'm asking? Huh? There's no side. I mean, don't say the y. 3x minus 4e, I have no control over that. That is always there. But I can make C1 and C2 whatever the shit I want to. So, is one solution to this 2 plus 3x minus 4 e to the x? Yeah, if it makes C1 2, it makes C2 0, and blah, blah, blah. You guys follow. But of course, the answer can't be 2e to the -2x because that makes the dE become 0. And what's the dE supposed to equal? 9x e to the x. Shit, that's why you always need the 3x minus 4e to the x piece. But then you can add whatever the shit else makes it 0 because it's not going to screw with that. Does that make sense? And I'm sorry if you don't like my less than technical way of explaining things, but that's the way I have it in my head. Okay. That's the way that makes more sense to me. Okay. All right. Before I go any further, I promised I would remind you about synthetics. So if you will suffer with me for a moment, and that's you guys are like, we are eternally suffering with you, Jeff. very quick. I'm just gonna do this shit. I'm gonna do long division, yes? Oh, so much fun. Okay. This is what I do on my Saturday nights. I sit around doing long division. Here we go. Change the signs, add, bring it down. I'm gonna do this fast. Don't even try to, I just wanna have this here so I can reference it. Change the signs, add, bring it down. You're probably doing it too fast, Jeff, but too bad.
Too bad.
Change the signs, add, I get minus 1 over x minus 1. Okay, I did that a little fast, but everybody with me so far? So long division of polynomials works the exact way that long division of numbers work because polynomials are numbers. Yes?
Where did this x minus 1? Is it just you just chose it randomly?
Yeah, the problem is this. This is the problem.
Okay.
And I want to simplify it. So one way to do it is to long divide. Real quick, do you see how this piece always cancels? It's dumb to keep writing the damn thing then. The only important thing is 4 plus 1 is 5. Negative 7 plus 5 is negative. That's the important steps. Do you agree with me? Because that's where these numbers came from. Right? So any shortcut method I'm going to use has to maintain those parts. So here's what synthetic... And the other sucky thing is, I don't know if you guys just notice this, x squared times x is x cubed, x squared times negative 1 is negative x squared, and then I change the sign, because when you do long division, don't you subtract? So I change the sign, because now I got multiple terms. So wouldn't it be better, number one, wouldn't it be better to not write all these damn letters? So I'm just going to write the number, but I'm also going to change the sign. Instead of changing the sign each time, I'm going to change the sign once at the beginning. If you remember synthetic, this is flow so far. Then I'm going to write the numbers. 1, 4, negative 7, 1, because they're already in descending order, and I'm not missing anybody. If I was missing an x term, I would put a 0 for it, just like we do in numbers. 1001 means I'm missing hundreds, missing tens. Shimo! Now watch this. This is cool shit. Bring the 1 down, because why did I put a 1x squared here? Because there's a 1 here. If there was a 2 here, I would have put a 2 there, correct? So in the answer, there will be a coefficient of 1 at the beginning. 1 times 1 is 1, 4 plus 1 is 5. 4 plus 1 is 5 is right there. Yes? 1 times 5 is 5, negative 7 plus 5 is negative 2. Negative 7 plus 5 is negative 2 is right there. So this is a shortcut. It just takes the most important parts of my work. Negative 2 times 1 is negative 2, and 1 minus 2 is negative 1. Bam! Bam! This was cubed. I divided by x shit, so now I'm going to have squared. Okay, that's synthetic division. You guys all with me? If you've never seen it before, that is probably not sufficient. But hopefully you can see, even though you don't understand why we necessarily set it up, though, you can actually see that it's capturing the most important parts of the work I did with the long division. Is that better? Is that coming back? So a really good question then is, okay, great. How does that help me?
Yeah, kind of. I was just wondering, one of the main problems was you needed to do that. And
Yeah.
I was just trying to do it normally, and I don't know how I was supposed to know. I was supposed to synthetically divide that rather than just.
Well, for one thing, I think they do talk about it in the book, if I remember correctly, somewhere. Screw it. All right. Let me give me a moment. I'm going to make the problem up. Blah 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 blah. Everybody, talk amongst yourselves. Let's see. This could be very exciting. Let's see. Alright, let me see if this works. Yeah, good. Alright, everybody shut up. So let's say I've got a DE, yes? There's my DE. It's in the witness protection program. I'm going to show you what it is. And I get an associated, what do you call it? An auxiliary equation that looks like this. Does grouping work? Because that's what you try if you have more than 3 terms, you try grouping. Does grouping work? I know right now, some of you guys sitting there in 285, right now you're going, I remember some of this shit, this factoring shit. You gotta bring it back, because a lot of the methods we're gonna use are gonna end up with a polynomial-looking equation that we must factor, because we're trying to get it equally here. So factoring's gotta come back. What synthetic division does is it's a tool to use when all my normal methods of factoring fail. You guys got with me? Now, real quick. I know. Can anybody tell me anything about the answer to this? If it's fully factorable, what is each one going to look like? Yeah, m plus or minus a number. That's what every one of these is going to look like, yes? Can anyone tell me about what these numbers might be? Could any of them be 7?
No.
Why not?
Because it's not factorable to 6.
Because it can't make 60, yeah. So what numbers could these be? Factors of 60. 1, 2, 3, 4, 5. Oh, here's a really cool thing, real quick. What's the square root of 60 roughly? A little bit under what? 8. Is everybody with what I'm doing right now? I'm trying to make a list of factors. 60 sucks because it's got a ton of factors. 1, 2, 3, 4, 5. Square root of 60 is a little bit less than 8, which means once I get to 8 or close to it, is the turning point. Here's what I mean by that. Doesn't 6 go in? What about 7? 8? Okay, it just hit 8, which means now I can start doing the pairs of shit. Do you understand what I'm saying? It's a very useful thing to know. Because now I'm at the point where I don't have to think anymore. I had to think for these, and now I can just pair shit up. 4 times what is 60? Good. 20, 30, 60. Okay. So there's all the things it could be. Are you with me? This is what's really weird for me is I just last week taught this same shit to my pre-calc class. This is weird. All right. So just to cut to the chase, can you synthetically divide this by 3 for me? Set it up for the synthetic. Just gonna, darn it. Screw it, I'm gonna do it with you. I wanna put one more thing in before I let you out of here, so. You guys help me out. What goes here?
1, 2,
Buckle your shoe nuts up. 9. This means you can win in evenly. What's the answer here? All right, where did this come from? Yeah. So we factored it. Can you factor this? It should be m's, but I'm okay. Whatever the hell. So m minus 3.
M plus 5 plus 1.
Plus. So then what are my answers?
3,
Negative 5, negative 4.
So then what's the solution going to be for the YC?
C1,
Blah, blah, blah. Okay, we know. So yes, there will be some situations, and it only makes sense. In the general sense of the word, the equations I'm going to have to solve are not something I construct. So if I end up with some auxiliary equation I can't factor in, oh shit, I need some way to do it, right? Now, at the same time, I understand. Whatever industry you go into is going to have some software package that's going to do this shit for you. We are still the humans. We still have to understand what it's doing, right? Just in case, I guess. Because I always get at least one person who goes, well, I'm just going to have shit that does it. Not in this class. Too bad. Okay. All right. Last thing I want to say, it's a little rushed, but too bad. We'll get into it more next time. There is a major, real quick, don't even look at this stuff. Let's just look at this. What's the auxiliary? So what are these solutions? I. So what's alpha? 0. And what's beta? 1. Stop for a minute. And by the way, I didn't have to do any of this shit. I didn't have to do any of this, but just to show you we get the same solution. Is this going to be e to the 0x, correct? E to the alpha x, that's 1, times cosine beta x plus sine beta x. And of course I'm going to put my C1 and C2. You guys with me? We already knew that was the solution to this dumb thing, correct? What function, the second derivative, is the opposite of the original function? Sine and cosine, right? We've looked at this one before, correct? We didn't do it this way, but it's nice to know that this funky-ass way to do it for much harder problems, it must still work for this easy problem. The process shouldn't change because of what's in the problem. It should be the same. Okay. So that answer I could have gotten simpler. Now, here's the problem. What am I going to assume is my YP? Just looking at this, what's YP going to be? B cosine x, yes? What is wrong with that assumption? We already know that anything of this form makes this dE equal to what? Frickin' 0, right? Shit! So therefore, what we do, we don't use that. We use something that looks very familiar. We use that. And it's related to the reduction of order thing. It's also related to the fact that the derivative of YP has a sine x and b cosine x in it, correct? Because that's going to be a product rule situation. I need you to understand. If my YC has the same functions my YP needs, YP cannot have that shit. It makes it 0. It doesn't make it 4 sine x. Therefore, it must be a funky-ass situation that involves the reduction order thing, and then I throw x on. What if my YC had C1x cosine x plus C2x sine x? Then I would just do ax squared sine x plus bx squared sine. I would just, and it would actually have more shit, but I just multiply by as many x's as I need so that my YP is not the same as my YC stuff. That was very quick, and I'm sorry, but we'll do some examples of that next time. We're way out of time. Okay. Have a good weekend. Do a lot of differential equation stuff. Okay.
Where's the other sheet? The other sheet?
Oh, this one?
Yeah.
Sorry. Here you go. And you got the first one I gave out?
No. I didn't get
Oh, the first one you didn't get?
Yeah.
Shoot. Never things end up in the middle of something. Hold on. It's not that. Give me a moment. Here we go. That's from last time, darn it. Where did I put it? They couldn't have disappeared that. Oh, here we go. Okay.
All right.
There we go.
Thank
Oh,
you.
that one's all marked up. Sorry, buddy. There we go. Sure.
Which file is this one?
One next to the camera. Well, sort of. Shoot.
Sort of.
I've got stuff to give back, but I forgot to
Later,
ask
homeworks?
later. Yeah, thanks.
Any of the homeworks or?
Some, but not all, for sure. What's your name again?
Thomas? Yeah, it's okay.
Forrester.
Yeah.
Okay, so I'm in the middle of doing
Okay,
this.
all
I'm
right.
sorry, man.
All right.
This weekend I'm gonna have a chance to actually catch up.
Okay.
Yeah, it'll be great.
All right.